graphing calculator that you can get online, and you can certainly do that if you don't have one, but you're going to want to have a graphing calculator for sure in this class. So let me just share my screen here and make sure that I get it to work. Okay, so hopefully you all can see my screen here. We're going to be doing section 1.5 and the first part of section 1.6. And then I also wanted to show you the weekly plan. This is my geometry here. Let's see here, this one. So today we are going to do a section and a half kind of. Tomorrow, we're going to do this mini lesson, and then I'm going to give you a review assignment of some type. I had originally said that we were going to do a quiz tomorrow, but I moved that to Wednesday. And then Thursday and Friday, we're going to do new lessons. And then on Monday next week, a review again, and Tuesday, a test. Okay. So just so you're aware, that is what we are going to be doing this week. Okay. All right. So today what we're going to do at first is learn how to graph linear inequalities. And then the second thing we're going to do is learn how to graph two equations on two different lines on the same graph and solve the system of equations. So the first lesson, we're going to be graphing just one line, but it's going to be an inequality. And this is something that you've learned in algebra before, so this should be something that is a review to you. And if you ever get an equation that's like 2x plus y is greater than or less than something, you're going to have a dashed line or a dotted line when you do that. If it were 2x plus y is greater than or equal to, or less than or equal to, then you have a solid line. So that's one thing that you're going to have to pay attention to. Okay. Another thing that is true is we are going to be making sure that our lines are in slope-intercept form, which I think you guys know from last week is y equals mx plus b, and we're going to use our slope and our y-intercept to graph the lines. And this is how I teach graphing given a slope. If my slope is positive, I go up and to the right. So if it's positive 2/5, let's say that that was my slope, I would go up 2/5, up 2/5, and so on. If my slope was negative 2/5, then what I do is I go down 2, and I always go the bottom number to the right. So if it's positive, I go up and to the right. If it's negative, I go down and to the right. So if I go to this first example here, notice that our slope is -2 and our y-intercept b is 4. So when I go to graph that, I go up to 4 and I put my dot. That's where it crosses the y-axis is your b. And you always have to make sure these equations are solved for y. Okay. Then what I do, this is going to be -2/1. That is my slope. And remember, if it's negative, what it says up here is you're going to go down and to the right. So from this point, we're going to repeatedly go down 2/1. Now, I'm super picky about graphs. So if you're going down 2/1, I don't just want you to make one point. I want you to keep doing that, down 2/1. And then you're going to use some type of a straight edge that you can find. You can use like open up one side of your book and use that as your straight edge. Or if you have a ruler, find something that is a straight edge, okay? And going down 2/1 to the right is the same thing as going up 2 and 1 to the left. Up 2, 1 to the left. So I want you to go and fill that entire graph. Once you do that, then what you're going to do is look at the sign and see if you're going to do a solid line or if you're going to do a dashed line. And I'm using my tablet, and so my lines are not going to be very good today. But if you would do your, if you want to just make sure that you use, especially on your assignment and like quizzes and stuff, that you use a straight edge, okay? Now what we have to do is decide which side we're going to shade on. And when I do that, I think somebody has their volume on. Just give me a second. I'll try to see who it is. Unless if it's just from me, I'm not sure. Okay. So then what we're going to do at that point is decide which side to shade on. And what I do in this situation is I pick the origin if our line doesn't go through the origin. If your line goes through the origin, you'd have to pick a different point, like 1, 0 or 2, 0 or something like that. But if it doesn't go through the origin, that's what I try. So I'm going to try the point 0, 0, and I'm going to put 0, 0 up into that original equation for x and y. Okay, so in for x, I put a 0, in for y, I put a 0, and then I see if this is a true inequality or not. So is 0 less than or equal to 0 plus 4? Is 0 less than or equal to 4? And the answer is yes, it is. So that means that where 0, 0 is where it should be shaded. So this graph should be shaded below. Now, what I do, just because I try not to make it messy, is I just draw arrows where it's supposed to be graphed. If you want to like lightly shade that in or whatever, that's absolutely fine. I just typically draw the arrows rather than shading it on the smartboard, okay? All right, so that is the first one. Now let's go to our second one here. And notice this one is not solved for y. So what that means is I have to solve it for y. And we've done this in our, like last week we did it. So when you do that, what you're going to do then is just bring your x over to the other side. So I'm going to subtract 4x from both sides, and I get 3y is greater than negative 4x plus 12. I always put my x before my constant because in slope-intercept form, my x is before the constant. Then I divide by 3, and I get y is greater than negative 4/3 x plus 4. Okay, so if you look here, my slope is negative 4/3 and my y-intercept is 4. So now I'm going to come back down here and I'm going to plot this line. So if I do that, I can go up to my y-intercept of 4 and put a dot. And then my slope is negative 4/3. When it's negative, you go down and to the right. So I'm going to go down 4 and 3 to the right and put a dot and keep doing that. Down 4, 3 to the right, down 4, 3 to the right. And that's the same thing as going up 4 and 3 to the left. And then you have to ask yourself, like, do I put a solid line or do I put a dashed line? And this one has just greater than. There's no equal to, so that tells me that I need a dashed line. Okay, so I have that dashed line there. And then again, what I need to do is I need to figure out where am I going to graph this, okay? Or where am I going to shade this? So I, again, am going to try the point 0, 0, because my line doesn't go through that. So it's okay to do that. And then I'm going to actually go back up to the original equation, 4x plus 3y is greater than 12. And I'm going to put 0 in for x and 0 in for y. And I'm going to see if this is a true statement. So 4 times 0 is 0, plus 3 times 0 is 0. 0 plus 0 is 0. Is 0 greater than 12? No. So what that means then is that I'm going to shade on the opposite side of the line away from the origin. So I'm going to shade this way. Because 0, 0 was not a true inequality, then I shade the opposite direction. Okay? And by the way, as long as I'm thinking of this, you guys are going to need graph paper today, and I know not all of you picked it up, so I want to show you really quick. If you go into Teams, okay, so if I open up our team and go to Files, there is a section. Am I in the right class? 5th hour advanced algebra 2. Well, maybe I'm lying. Maybe for your class I don't have one, but I can do that really quick and make graph paper. Okay, so I'm just going to make one that says graph paper here. And then I'm going to load the graph paper for today so that you have it. And I'll also add it under, I think this is the one that I want to load. Let me just make sure. So if you're printing this, yeah, this is the correct one. You should print several sheets and try to print back to back if you can. And then I also wanted to show you, as long as we're in here, keep in mind that there is, gosh, I must not have put weekly plans in here for you.
Geometry.
Am I really?
Yeah.
Oh, that's why. That's weird. Okay, I'm going to delete that then. Thank you. See, I was looking up, I have like my little team meeting. Sorry, thank you. So if I go into our class and under files, here's the graph paper. And the one that I would suggest for today is just the normal one, not number 2 or number 3, just that one. Okay. And then also, if you're still confused, go to weekly plans. And if you go to week 2, it'll have a link to where to go for the assignment for today. So you can link into that. And then here under your assignment, I can also put that graph paper. So let me just do that super quick too. And then you should be good to go. All right. So it's in both places then. So if we go back to where we were and go back to my screen. Okay. All right. So now what we're going to do is go to this problem. And again, this one is not solved for y. So I need to do that. So the first thing I'm going to do is get rid of this 2 by subtracting 2. And I get negative y is greater than x minus 2. And then what I'm going to do, I can't have that negative there. So what I'm going to do is I'm going to divide everything by a -1. And you have to remember that when you divide by a negative or multiply by a negative, you have to switch your sign. So it's going to be -x plus 2. Now what I can do is think about how to graph this. So my slope is what's in front of the x. So that's like a -1 over 1. And my y-intercept is 2. So if I go to my graph, I'm going to go up to 2. And then my slope is -1 over 1. So this one's going to have a lot of dots. You're just going to keep going down one to the right. And then you can keep that pattern, go up 1 and 1 to the left. And you'd see where that graph should be. And we have to think about, should this be dashed or should this be a solid line? And because it's just greater than there, that means it should be dashed. Okay, so you just somehow want to show that this is dashed and make sure it's not solid. And try to use a straight edge. Okay, now what we're going to do is see where we should shade it. So to do that, if my line doesn't go through the origin, that's what I try. So I'm going to try 0, 0 into that original equation, which was 2 minus y is greater than x. So if I put 0 in for y, 0 in for x, basically what we're asking ourselves is 2 greater than 0? And yes, it is. So that means that it's going to be shaded towards the origin. So it is going to be shaded down here. Okay? All right, so now if we go to this page, I was saying last week, I believe I said this to you guys, that you may want to have like one sheet of notes for the quiz that's going to be on Wednesday. This may be something that you want to write down. So if you ever got something like x is equal to -2, it's going to be a vertical line, and you would go on your x-axis to where it's -2, and then you would just draw a vertical line. And yours should be straight, mine's not. If you got y equals a -2, then you'd go on your y-axis to where y is -2, and you would draw a horizontal line. So whenever it's x equals, it's vertical. Whenever it's y equals, it's horizontal. So this one here, they want us to graph. And to graph it, I have to solve for x or y usually, but I don't have a y now, so I'm going to just solve for the x. So when I divide by a -3, you'd have to remember, because you divided by a negative, you're going to switch your sign. So it's going to be less than or equal to -3. Now, because I only have the one variable, that tells me that it's one of those special cases. And remember, when it's x equals something, it's a vertical line. So you go to where x equals -1 on your graph, and we would do a vertical line there. And notice this one's greater than or equal to, so it's going to be a solid line at x equals -3. Now I still need to decide, where am I going to shade? Okay, so I can try 0, 0 again. Now in this one, I can use that original, -3x is greater than or equal to 9. And I can just put my 0 in for x, because that's the only variable I have. Okay, -3 times 0 is 0. Is 0 greater than 9? And it's not. So what that tells me is that it's not going to be shaded at 0, 0. It's going to be shaded the other side. So it's going to be shaded this way. Okay, and remember you can use 0, 0 anytime that your line doesn't go through that. Now if I look at this one, I have it solved for y and there's no x, so that's another of your special cases. And if you look up here, if it's ever y equals something, it's a horizontal line. Okay, so you're going to go to where y equals 6 in this case, and you're going to draw a horizontal line. So I'm going to go on my y-axis to where y equals 6. And now I have to think about, I know I draw a horizontal line, but do I draw a dashed line or do I draw a solid line? And I would draw a dashed line because it's only less than. Okay, so that's my graph. And then if I try the point 0, 0 and I put 0 in for y, is 0 less than 6? Yes. So that means I'm going to shade where the origin is. So I'm going to shade going down. Okay. So that is how to do the first section today. And now we're going to go to our second section. And this is on solving systems of equations, which means that you're going to have two equations with two variables. Okay. When you do this, you can have one of three scenarios. One is the two lines, when you graph them, can intersect at a point, and whatever that point is, that is the answer to, that is the solution between your two equations. Okay. Another option you'd have today is you could have two parallel lines. And from geometry, you know that parallel lines never intersect. So the intersection is the answer or the solution. So if they don't intersect, then you have no solution. And another scenario you could have today is when you solve your equations for y, say that this was y equals 1/2 x minus 6. Okay, and then you have another equation and you solve it for x, and it's exactly the same line. What would happen then is your lines would be the same. And again, your solution to those two equations is where do your lines intersect? And here they intersect every single point on the line. And so that is why there is infinitely many solutions whenever you get the same line. Okay, so we're going to start this first one, and what happens in this one is we're given two lines. We have two equations with two variables, and for today we're learning how to solve this by graphing. To solve this by graphing, what you have to do is you have to take that equation and solve it for y to put it into slope-intercept form. Okay, so I'm going to try to bring that 4x over by subtracting 4x. And when I do that, I get 3y equals, and then I put my x in front of my number. So negative 4x plus 24. And then I'm solving for y, so I'm going to divide by 3. And I get y equals negative 4/3 x plus 8. So 4/3 is already reduced. 24 divided by 3 is 8. So then what I would do is I can now graph it. I know my slope is negative 4/3, and I know my y-intercept is 8. So on my graph, I'm going to go up to 8. And then I'm going to, if my slope is negative 4/3, I go down 4/3, down 4, 3 to the right, down 4, 3 to the right, and so on. So here we have solid lines. These are not inequalities in this second section. These are just going to be solid lines. They have an equal sign, okay? Then what I'm going to do is take my second line, which is negative 3x plus 5y equals 30, and I'm going to solve that for y. So I add 3x, and whoops, what I would get is 5y equals 3x plus 30. Divide by 5 on all of these, and I would get y equals 3/5 x plus 30 over 5 reduces down to 6. Okay, so now I can go and graph that. So I'm going to go up to 6 and put my dot, and now this one is 3/5. So you go up 3 and then 5 to the right, which is the same as going down 3 and 5 to the left. Okay, so my line, and you should use a straight edge, is going to look something like this. Now, what you're looking for on this is you're looking for where do these intersect, okay? We can tell they intersect somewhere here, but we're not quite sure where. And because my lines aren't completely straight, I'm going to have a less accurate estimate than what you are. Now, when you look in the back of the book, they may give you just an estimated answer, but if it's not on an exact point on your graph, what I'm going to do is show you how to use your graphing calculators to find the exact point. And you're going to notice we use our graphing calculators quite a bit in this class. So what I would like you to do is take out your graphing calculator and go to your main screen and clear anything that's there. And then what I would like you to do is go to your graphing calculator, and this right here is something you should only have to do once. But if you ever are getting an error when you go to graph lines, this is something to check. So if you hit your second key and then your y equals, you should get this. And one thing that happens, especially if you're in Intro to Stats with Mr. Ilias, or if you're using a siblings calculator and they've had that class, you'll have some stat plots that are on. We want to turn them off. And how we do that is you could just click or hit number 4 and then hit enter, or you can use your down arrow and go to number 4 and then hit enter. Okay, that will bring up this screen that says plot off, and we do want to shut them off. And they're not off yet. What we have to do then is hit enter, and it should say done. If you're the first person who's ever owned this calculator, chances are they were already off, but this is something that does happen, and we have kids not be able to graph lines because of that. So now I'm going to show you how to graph a line. And so what I'm going to do is have you go to your y equals key in the upper left-hand corner. If you have anything in here at all, you're going to want to go, and mine is being kind of stubborn, and you want to delete or clear. You should be able to go on that line and just hit clear. You don't want anything on any of these, okay? So go to, if you had something for Y2, go there and hit clear. All right. Sometimes you'll get something like I did at the beginning that was a little bit tricky to delete. Sometimes you have to go on it and hit your DEL key to delete it.
Wait, how did you get there again?
I went to Y equals in the upper left-hand corner. Do you see the gray keys on the top? The Y equals. Does that help?
Yep, thank you.
Okay, so now what we want to do is put in our equation in slope-intercept form. And our first equation is -4/3 x. Because it's a negative fraction, we have to put that in parentheses. So we're going to come down and we're going to go to our parenthesis, and then -4 divided by 3 is our fraction, and we have to do another parenthesis. So whenever you have a negative fraction, that's how you're going to have to do it. Then your x, to get your x, it's to the right of the green alpha key. It says like x comma t comma, and then it has a theta and then a comma n. If you just click it once, it'll give you an x. And then just go +8. Now, one thing I should have said at the beginning, when you do your negative sign, make sure that you do the negative to the left of your enter key on the bottom right corner. Use the negative sign to the left of the enter key. Do not use your subtraction sign for a negative sign, or your graph won't work. If you did that, you could go back to it, go back here with your left arrow, go to this and make sure you used your negative sign. Now we have that one in, so now we're going to put the other one in, and this one is y equals 3/5 x. Now this one's positive. You do not need to use parentheses if you have a positive fraction. If you want to stay in the habit of putting fractions in your parentheses, do that. But if you're putting it in here, you don't have to. So we can go y equals 3/5, hit your x again, and then go +6. Okay. Now another thing that you're going to have to really learn in this class is how to adjust what you want your y-axis to be counted by, and how big and small you want it, and what you want your x-axis. So let's go to our window, and this is the most general window we do. So for x min, if yours isn't like this already, go down to your negative key and make that -10. That means on your x-axis, you're starting at -10. For your x max, we put it at 10. And then what the x scale means is what do you want to count by? And we're going to count by ones. Then if you go to your y min, that's on your y-axis. What do you want your smallest number to be? And we are going to say -10. Your y max, we're going to say 10. And your y scale is 1. So this is kind of your typical window that we use. Now what we're going to do is hit graph. And you should get 2 lines that graph. If you have the CE edition of the calculator, your lines are going to be colored. If you don't, you're just going to have black lines, which is fine. Now you can see where these 2 lines intersect, but we can't tell exactly what points those are or if it's an exact point. So what I'm going to do is show you a really quick and easy way to see where they intersect using the calculator. So what we're going to do is go back to our second key, which is the blue key, and then we're going to hit on the top row, the 4th one over, the gray key that says trace. We use this a lot, okay? We go second trace a lot. Now what we want to do is we want to find where do those lines intersect. So we want to go down to number 5 and then hit enter. Okay, what it's asking us now is what curve do you want as your first? Say that again.
Sorry, I don't see that in my calculator. I clicked second and then trace, and then the only thing I see is value. I don't see it below value.
You don't have 0, minimum, maximum?
No.
Is yours an older calculator or?
Mine is the TI-84 plus CE.
Oh, Gosh, that's weird. I think what we're going to want to do with yours is reset it because that's the newest calculator there is. And so why don't you stay after today, and then I will talk you through resetting it, and then hopefully we can get that to come up.
Right.
Okay. All right. So now, like I said, we're going to go down to number 5, hit enter. And when it says first curve, mine's on the blue one, which is fine. And then I just want to, that cursor's on blue, so I'm going to hit enter. It shows that blue one as my first line. Now notice your cursor jumps down to the second line onto my red line, which is good. So I hit enter again. And now it wants us to guess what point it is. I don't even do that. I just ignore that it's asking us to guess, and I hit enter again, and then it tells me the exact point where that intersects. And so I always round these to the nearest hundredth, so the exact intersection is 1.03, and then the y is 6.62. So if I go back to my screen, my actual answer for this one is going to be the 1.03, 6.62. And that's not something you could have been able to tell by looking at the graph. Usually when they give you graphing problems, they should give them to you so that they intersect on an actual point on the graph. And the ones I noticed that were on the quiz are like that. But for this, for some of them that we have, they might not be that way, okay? And you can use your calculator on the quiz and on the homework to find that intersection, but you do have to graph them still, okay? All right, so now let's go to our second problem here from this section, and we are going to try the first line and solve it for y. Okay, so what I'm going to do is add 2x, and then I get 5y equals 2x plus 10. Then I divide by 5, and I divide everything by 5, and I get y equals 2/5 x plus 10 divided by 5 is 2. So now I'm going to go ahead, my slope would be 2/5, my y-intercept would be 2, and I'm going to go and graph that. So I'm going to go up to 2 on my graph, and then my slope is 2/5, so I go up 2 and 5 to the right, and then up 2 and 5 to the right, which is the same as down 2 and 5 to the left, and down 2 and 5 to the left. And then draw that line. All right. Now we have to do the same thing with the other line. So I'm going to go to 4x minus 10y equals negative 20. And I'm going to solve this for y. So I'm subtracting 4x. And I get negative 10y equals negative 4x minus 20. I always put my x first. Then I divide by a negative 10. And y would equal, now a negative divided by a negative is positive, and 4/10 is 2 goes into each of those, 2 goes into 4 twice, 2 goes into 10 5 times. So this would be 2/5 x, and then again a negative divided by a negative is positive, and 20 divided by 10 is 2. So now I'm going to go and notice that the line here on this side was y equals 2/5 x plus 2, and this line is y equals 2/5 x plus 2. They are the same line, and when they're the same line, you can't graph one on top of the other because they are the same line. And what happens is every point on that line is a solution to this equation. So what your answer would be is infinitely many solutions. Okay, so you're kind of going to like those because they're quicker. All right. Now, if we go to our last problem, I can take that first equation and solve that for y. So I'm going to subtract 3x, and I get 6y equals negative 3x plus 30. Divide by 6, and y equals negative 3 over 6 is going to reduce down to negative 1/2 x plus 30 divided by 6 is 5. So I'm going to go ahead and graph that line. My slope is negative 1/2. My y-intercept is 5. So I am going to go up to 5 and put my dot for my y-intercept. And then my slope is negative 1 over 2. So I'm going to go down 1, right 2, down 1, right 2. Okay, which is the same as up 1, left 2. And then you can draw that line. Hopefully you have a straight edge of some sort. Okay, and then we need to do the same thing with this. So 2x plus 4y equals negative 12. And I'm going to solve for y. So I subtract 2x. And I get 4y equals negative 2x minus 12. Divide by 4. And y equals negative 2 over 4 is going to reduce down to negative 1/2 x. And negative 12 over 4 is going to be minus 3. So I have a slope of negative 1/2. I have a y-intercept of negative 3. Okay, so if I go to graph that, I go down to negative 3, and my slope is down 1 over 2. Down 1 over 2. Okay, and I can keep that pattern going, up 1, left 2. And then graph that. Now, if you notice on this graph, these two never intersect, and they look like they're parallel. And if you guys remember what it means for two lines to be parallel, they're going to have the same slope. And these two do have the same slope. So these are parallel lines. And whenever you have that, it is no solution. So you can have one solution, which you can find most of the time, you can find it on your graph because they're going to intersect on a point on the graph. You can have no solution when they're parallel, or they can be the same exact line, and then it's infinitely many solutions. Okay, so your assignment to do for tomorrow is this. Our quiz, again, I switched to Wednesday. Okay, tomorrow we're going to do just a really short lesson that last time I did on the same day of the quiz. But tomorrow I'm going to do that and then give you review assignment. And so today you have two different assignments. And this is something I haven't talked about yet. The book talks about labeling things as consistent and independent, or inconsistent. We are not going to do that. So you do not have to do that part. Ignore that. You're just going to graph the two lines and say what the solution is if they do intersect, or infinitely many if they're the same line, or no solution if they're parallel. So you can ignore that. And then hopefully you can print off that graph paper. If you don't have means to print it, then I would come into school at some time between 7:30 and 3:30 and get one of my folders, or just grab graph paper from me, okay? All right, so that is it. Once you are done copying this assignment down here, you are good to go for the day. And then I will be back tomorrow. Quiz on Wednesday. Have a great day, guys, and send me a chat if you have any questions at all. And then whoever it was that had that issue with their calculator, why don't you stay after and we'll try to figure that out, okay? Have a great day, guys.